So we are discussing how we can generate electricity by renewable energy sources. Renewable energy sources means the resources which can be replenished over a short time, like amount which we are using and the rate which we are using is very small as compared to rate at which they are formed. So it is readily available or available. So we discussed the first one was solar panel, the second one was the hydroelectric, and the third one is wind energy. About the wind energy, as we already discussed yesterday, that what happened, how the moving air is produced. So same idea, that the source again is the sun. For wind and wave energy, the source is the sun. So what happened, because most part of our earth is having water, and very small proportion is there compared to water, small proportion is there, that is land, but greater proportion of our earth is occupied with water. So when the heat energy from the sun, it provide heat to both land and sea, but because the amount of land, the size of the land is very small, amount of land particles is very small as compared to amount of water particles. So water can absorb greater amount of energy, land can absorb small amount of energy. So if land cannot absorb energy, what will happen? It will start to radiate that energy, it start to give out that energy, and it will give that energy to the air above the land. So these are the air particles above the land, and these are the air particles above the sea or water. So when these air particles above the land, when they absorb energy, they will become hot, and hot air will always rise. Why hot air will always rise? Because it's having low density, its volume is more, its density is low, so the hot air particles will always rise. So when these hot air particles will move, they rise, so the amount of air particle decrease in this region. So as the amount of air particle decrease above the land, so as the amount of air particles decreases above the land, so the air particles which are above the sea will start to move towards the land, and this movement of air particles from sea to land, this will create a moving air, or we also call that as a wind. And when this wind is blowing or moving over the surface of the water, what it create? It create waves. That's how the waves are formed on the water surface. So this is how the wind is produced. So again, what is the source of this wind? The source of the wind is the sun. So what we can do, we can use these windmills to generate electricity. So how it works? So first what happened? There's a moving air. When the air is moving, what it would, it collide with these blades of the turbine, this windmill. So wind blowing past the turbine rotate their blade. So when it rotated, the kinetic energy is transformed into mechanical energy of the turbine. And when there is a turbine, it is connected with a generator. So generator produces electricity, and we use transformer. The transformer convert the electricity to appropriate voltage, and we transfer that to the consumer. But again, this is not a reliable source. Why it is not reliable? As the wind speed from day to day it varies, it's not constant. A wind speed varies, so amount of energy which is coming out from these windmills, that will also vary. So kinetic energy of the wind converted into kinetic energy of the turbine, and that produces electricity, connected with a generator which produces electricity, and that electricity is transformed into specific voltage by using a transformer, and it is transferred to us. Is it clear? The concept of the windmill, how it can be used to generate electricity. So what are the energy conversions here? The kinetic energy of the wind, because the wind is moving, so it will have kinetic. That will turn into mechanical or kinetic energy of turbine and generator, and that produces electricity. What is a block diagram? Like the what we are using, we use a wind turbine here, we use generator, and we use transformer. What are advantages? It is a renewable energy source and it does not pollute the environment, no pollution. But what are disadvantages? Wind is irregular. Again, sometime if you have windy weather, in that case it will give a more output or higher output as compared to a calm weather. Then, but it produces lot of noise. What generator do? Generators are used to produce electricity. Generator is a device which convert the kinetic energy to electrical energy. So the main purpose of the generator to convert kinetic to electrical. And turbine rotate. So when the turbine rotate, it rotated the coil in the generator. The working of the generator we'll discuss in block 4. But they are noisy, it produces lot of noise, it occupies a lot of space, and power generated is relatively small. It does not generate too much electricity. So there should be a lot of windmills installed. And what could be a best place to install these windmills? So at a coastal area or a seashore, it is best because at that place you have a continuous moving air. So at a seashore or a coastal area, these windmills are suitable compared to a landlocked area. If a landlocked area is there, means land is surrounded by more land. In that place, it is not useful. Is it clear? The windmills. Then geothermal energy. What is a geothermal energy? From the name you can understand, like you study a subject, geography, geology. So when this term geo is there, that means earth. So geothermal means, and thermal means heat. So when we use the heat energy of the earth, we call that energy as geothermal. So how we can use this? As we know, there are 3 layers: crest, mantle, and core. The core, the hottest layer is the core, then there's a mantle, and the top layer is the crest. So what happened? This core is producing heat energy due to nuclear reactions inside the core. What it produces? It produces heat. So how we can use this heat energy from the earth to produce or generate electricity? So this is the surface of the earth crust. We use underground pipes for this, and one side of the pipe we add water. So when we add this water, and these are deep. The pipes are not exactly at the surface, it is drilled deep down to the earth. So the energy which is released from the core, this water will absorb energy from this. So water absorb energy from the earth core, and this water will convert into steam, because water absorbing energy convert into steam, and this steam will rise, because steam is hot, hot particles always rise. So when this steam will rise, at the outside what we have a turbine. So at this part we have a turbine. So when the steam particles collide with the turbine, it will rotate the turbine, and this turbine is connected to generator. So when turbine connected to generator, the generator convert the kinetic energy to electrical energy. So this is how we utilize the heat energy from the earth. Is it clear? The concept of geothermal. Geo means earth and thermal means heat. So how we utilize the heat energy from the earth, we call that as a geothermal. But again, it's not like feasible for all the places, because even on the crest, some parts of the earth are too hot. Like this is more suitable at a site where you have a volcanic eruption, because when you have active volcanoes, the earth crest is at a higher temperature as compared to a region of inactive or volcanoes. So the site of active volcano, you can make a pipeline and you add water which convert into steam, and that will rotate the turbine to produce electricity. So this is what is how it is done. We add a cold water, the cold water absorb heat energy, turn into steam and hot water, which is connected to turbine and generator, produce electricity. This is also cold water or normal water. You can also say cold water or normal water. That's the same thing, no difference. As you can see here in this one, so this is injection well. What is the meaning of injection well? Where we are adding a water. And what is the meaning of brine? Brine means salty water. Why we use a salty water? As we discussed, that if a salty water is there, it will have a higher boiling point. So it will boil at a high temperature. So it can absorb more energy. So we add water here, injection well. That water will become warm or convert into steam. So as this steam rises, this is the steam coming out. So what it do? It rotated the turbine, and these turbine are connected to generator which produce electricity. You don't have to learn the labels of this. Why we prefer a salty water? Because salt water, it will convert at a higher temperature. So as it convert at a higher temperature, it can absorb greater amount of energy or take out greater amount of energy from the earth. If we use a liquid of low boiling point, it will be easily vaporized. It will vaporize easily, but it will not bring too much energy from the earth. But as water will have a higher boiling point and salty water will have a higher boiling point, so it will take out or remove more energy from the earth. Is it clear, this concept? About the geothermal energy. So geothermal energy is not from the sun, is it actually from the earth. So energy conversion that take place in a geothermal power stations, a geothermal energy or heat energy from the earth converted into kinetic energy of the steam. that mechanical energy of turbine and generator and produce electricity. The block diagram, what we use hot rocks, turbine, generator, and transformer. And what are advantages? It's renewable, it's having a low running cost, high power can be generated, but disadvantages, it releasing steam to the atmosphere. So if in our atmosphere, if we have too much steam, the water can also lead to global warming. Amount of water vapor, because the earth, too much steam in the earth atmosphere means the temperature of the earth will increase, so it can lead to global warming. This technique is very expensive process, because to locate a place where this power station can be built, then to drill down deep into the earth crust, and all the systems which are used here to install them, it costs a lot, and it destroy the land area, because the part where you drill, you cannot use that for any other purpose, so it destroy the land area. Is it clear about the geothermal advantages and disadvantages? Heather, Shahzeb, Saim, Abdullah Khan. So all these, what we discussed till now, were generating electricity from renewable, but now it is non-renewable energy sources such as coal, oil, even formation of the fossil fuel such as coal, oil, or gas. What is the source? How they are formed? The main source is the sun. But how fossil fuel are related to sun? So it's like about 200 million years ago. So about 200 million years ago, there were plants on the earth as well. So what happened to these plants? So these plants absorb energy from, so these plants absorb energy from the sun. When these plants absorb energy from the sun, as they die, so these plants are covered with a layer of sand and silt. So the layer of sand and silt will cover them. So when these sand or silt will cover them, so what happened to these plants? Gradually, these plants will convert into coal. Or even if some animals are eating those plants, some animals eat those plants and these animals die, and they are also covered, their bodies covered with a layer of sand and silt. So what they will convert into? They will convert into oil. So basically the formation of coal and oil is from the plants and animals which died about 200 million years ago. So main source, the start of this energy, because they take energy from the sun, and when they died, their energy they changed to coal. So the main source of fossil fuel is the sun as well. So when we want to generate electricity, we can generate from non-renewable resources such as fossil fuels or coal, oil, or gas power station. What happened? This is a simple diagram for how to generate electricity by using a coal. So first, as you can see, we at the bottom we burn the coal. So moment when we burn the coal, this water absorb energy from the coal and it will turn into steam. As this water turn into steam, the steam will rotate the turbine, and the turbine is connected to generator which will produce electricity, and the remaining steam will return and condensed. It will condense and form the water back again and absorb energy, turn into steam, rotate the turbine, then return back. So it is a cycle which continue until we burn the coal. So which form of energy this coal will have? Which form of energy this coal is having? The form of energy which this coal is having, kinetic, potential. No, it is releasing heat energy, but which form coal is having? Coal is having chemical energy. Whenever any food or fuel is there, coal is having chemical, but that chemical energy is turned into heat energy. And then heat energy convert into kinetic and then to electrical. So whenever you have food or fuel, they all have chemical energy. So what is the energy change? The chemical energy in the fuel convert into heat energy, then to kinetic energy of steam, then mechanical energy of turbine and generator. At the last, it produces electricity. What is a block diagram? We use boiler in which we keep the water. That's called a boiler. Then we use turbine, and then we use generator at the last, transformer. What are advantages? It required less space, but it produce harmful gases. It can produce gases which can lead to acid rain or global warming. It is having a high running cost because once you burn coal, you have to buy another sample, another slot. You cannot use the same coal again and again. Is it clear, the concept of coal power stations? Any question or a doubt in this? Then we have a nuclear power station. What happened? Nuclear power station is similar to coal, but the only difference here, we use nuclear energy instead of chemical energy, or we use a nuclear fuel. So the only difference what you see here between the nuclear power station and chemical power station is the fuel which we use. So what we use a nuclear fuel, or also known as fuel rods. So this nuclear fuel or fuel rods will have nuclear energy. Then we target this by a neutron, and we break the heavy nucleus into lighter one. So if heavy nucleus break down into lighter, what we call this process? Which nuclear reaction? Fission or fusion? A heavy nucleus break down into a lighter one. So we call that as a fission reaction. So by the nuclear fission reaction, the nuclear energy converted into heat energy. And this heat energy absorbed by the water, which convert into steam, and this steam rotated the turbine. As the turbine rotated, it produced electricity, and we use that water again in a cycle. So it's the same concept, but the only difference is the nuclear energy. That the origin, the starting point is a nuclear energy. So as you can see here, in this one, First, we have these these control. What is the purpose of the control rods? Because we want to control them, control the nuclear reaction. That's called a control rod. And there are fuel rods as well. Fuel rods means the nuclear fuel. So when we carry out a nuclear reaction, the water will convert into steam, and this water which converted into steam, as it moved, it rotated the turbine, and when the turbine is connected to a generator, this is a picture of generator, this is called a coil of generators. When it rotates, it produces electricity which is transferred to the consumer. But the problem with nuclear power station, it produces harmful radiations which are dangerous, which can cause cancer. So it cannot be built near the populated area, it must be far away from the populated area. So what is a block diagram? We have a nuclear energy changed to first here you have a nuclear reaction. Inside the nuclear reactor, nuclear vessel, it is a nuclear reaction that produces heat. And that heat energy is absorbed by the water. So when this water absorbs heat energy, it converts into steam. And that steam rotated the turbine which is connected to generator produce electricity. So the nuclear energy by a nuclear fission reaction converted into heat energy. Is it clear, Abdullah? Abdullah Sarfraz. How heat is formed when the heavy nucleus is having a nuclear energy. When we target this heavy nucleus by a neutron, it breaks down into lighter nuclei. So when it breaks down into lighter nuclei, what happened? Then initially there's a nuclear energy, but when this nucleus breaks down, it produces heat energy. And that heat energy convert the water into steam, which rotated the turbine produces electricity. So we have a nuclear energy converted into heat energy, that converted into kinetic energy of the steam, rotated the turbine, produced electrical. The block diagram, the nuclear reactor is there, then the turbine is there, generator is there, and at last transformer. What are environmental impacts? It pollutes the atmosphere due to a large amount of smoke and fumes, and it is dangerous to human body. And the radioactive material mixed with water, and water become radioactive. So, like what happened? It is emitting out harmful radiations, and these radiations, when water is exposed, these radiations, the water is exposed to radiation. So this water also become radioactive. The term radioactive means the water will start to emit out these radiations as well. And if someone will drink this water, it can develop a cancer, or it contaminated the water may leads to different types of disease. Is it clear? The nuclear energy. Then the last one, this water is there in this water is obtained from the sea. The last one is the tidal energy. You have noticed this, that the level of the water changes time to time. So as the level of the water you have seen changes time to time. What is the reason for this change in water level? This change in water level is due to the attraction of the moon, and this is called a tidal energy. When the water level changes, maybe you have noticed, if you are staying at a coastal area for about like 6 to 10 hours, you have seen that the water level is continuously changing. The position at which you see the water at 10 is different from 12, and at 12 it is different as 2 p.m. So what is the reason for that? The reason of change in level of the water is due to the attraction of the moon. The moon is also attracting the earth, and that attraction is more visible on the water. As this water level is continuously changing, this energy refers to tidal energy. So tidal energy, the source is not the sun, the tidal energy source is the moon. So when what we have discussed till now, the different forms of energies. So three forms of energies, the source is not the sun. Which three forms? The source is not the sun. As you can see, the sun is source of all energy resources except geothermal. Geothermal, it's energy from the earth. Nuclear, it's energy from the atom, the nucleus of an atom, and tidal is due to the moon. Rest all of the energy, rest all of the energy is due to the sun. Yeah, the moon is attracting earth, and its attraction is more visible on the surface of the water, as and that water level changes, we call that as a tidal energy. Is it clear? So today what we have discussed, we started with the concept of energy sources. Some are renewable, some are non-renewable. Then how we can generate electricity. There are different ways we can generate electricity from renewable sources, such as solar energy from a sun. We use solar panels. We can generate electricity from the water, the moving water. We call that as hydroelectricity or hydroelectrical energy, by storing the water behind the dam and produce electricity. We can also use the wind energy by using these windmills to generate electricity. That source is also a sun. We can use the geothermal energy, the energy from the earth's core, but the source is not the sun here, because that's generated in the earth. So sun is not the source of geothermal. We can generate electricity from non-renewable energy resources such as coal, oil, or gas. So burning the coal, we can generate electricity. Using a nuclear fuel, we can also generate electricity. So these are the power stations which you have to learn. And the tidal is only the one. You don't have to go in detail for the tidal energy. Just you have to understand the concept that the tidal energy is due to the attraction of the moon on the surface of water. Okay. The table gives four energy sources and state whether energy sources derive from the sun. Which row is correct? A, B, C, or D? Everyone should participate. Geothermal, it is derived from the sun. That's wrong. Geothermal is from earth. Oil, coal, oil and gas, the source is the sun, so it should be yes, but it is written no. Water behind the dam, the source is the sun. Yes, because the water evaporates and form rivers, lakes, and that's we store. So that's why C. Wind energy, the source is sun, but it is written no. That's why C is the right answer. Which source of energy uses the production of steam to generate electricity? In which one we produce steam to generate electricity? Hydroelectric, nuclear, tides, or waves? In hydroelectric, we do not convert the water into steam. That's wrong. Because in hydroelectric, we allow the water to flow. We store the water behind the dam, and as the water flow, the potential energy change to kinetic. But in a nuclear, first we have a nuclear fuel which produce heat energy, and that is absorbed by the water, which convert into steam, and the steam rotate the turbine which generate electricity. So B will be the right answer. Is it clear? Discussion. Yes, Heather, Hiba, Abdullah, Shazib, Afreen. Which row describe an advantage and disadvantage of wind turbines? So what is the advantage of wind turbines? We don't need fuel, that is the advantage. And no harmful gases released. But what is the disadvantage when we check harmful gases? So that's wrong. It does not produce harmful gases. But disadvantage, it has a variable supply. Like some days you have a greater output and some days you will have a smaller output. So it does not have a constant output. That's why C will be the right answer. Which energy resource does not have a sun as the original source? Like which is not derived from the sun, which is not originated from the sun. Coal is originated from the sun. Coal, because the formation of the coal is the heat and light energy from the sun absorbed by these plants, and when they die, they decay and they form coal. Geothermal, that's right. So sun is a source for coal, for hydroelectric, and for wind. Geothermal is basically the energy from the earth. The source of solar energy in this, take the box next to a resource for which the sun is also a source. So coal, yes. Hydroelectric, yes. Wind, yes. Is it clear? This one? Because geothermal is basically due to earth and nuclear is due to atom of the nucleus. So this was about the energy.